Hi, I'm Maxim Nadutenko from Ukrainian Lingua Information Fund of National Academy of Sciences of Ukraine, and today we're gonna talk about ontology-driven lexicographic systems. Interaction in the modern information space has a network-centric characteristics and is implemented through active information processes. The effective implementation of these information processes necessitates the existence of consistency condition that is imposed on active information processes, which determines network centricity. The implementation of this consistency condition lies in the definition and the use of linguistic constructs that can ensure consistency in the interaction of information processes. The lexicographic systems are such constructs both in theoretical and practical terms. They are able to provide a condition for consistency by taking into account the hyperinductivity of semiotic and semantic features of each subject area. So we will describe the standard lexicographic systems, the model of ontological lexicographic system as the extension of standard system, and the use of ontological lexicographic system for transdisciplinary integration of information. Lexicographic system is considered as semiotically and semantically organized information environment in which a certain set of lexicographic effects is implemented. L system operates as a set of elementary information units that belong to a given subject area. The lexicographic system consists of full semantic description of the information unit, formal part, content part, and the relevant mappings, as you can see on the slides 5 and 6. The architecture of lexicographic system is derived from three-level and C-Spark architecture. There are three levels of data representation in this architecture: conceptual, internal, and external, as you can see on the slide 7. Using ontologies in the form shown on slide 8 allows efficient storage of the information inside lexicographic system. This information is not limited to elementary information units and can include additional information related to system functioning. This creates an ontology-driven L-system architecture as an extension of lexicographic system architecture as shown on slide 9. The ontology-driven interactive document is a software system derived from the ontology-driven internal model. Such document consists of a set of ontologies, both informational and control ones, and a natural system which allows user to interact with information. An implementation of ontology-driven L-system architecture is shown on slide 10. An implementation consists of two subsystems: server-based information retrieval subsystem and browser-based information presentation system, which work in parallel to provide user with information required for solving a task. Both subsystems are characterized by the fact that they use ontologies as the medium for storing all kinds of information, both intermediate and resulting. A transfer between the subsystems is carried via local network or internet in the form of ontology files. The COVID-19 transdisciplinary cluster is an example of thematical ontology-driven L system that provides access to wide array of different information resources in different disciplines related to a study of COVID-19 disease, including those from thematical informational databases like medRxiv and bioRxiv. The COVID-19 transdisciplinary cluster is a web-based, publicly available, knowledge-oriented information system that comprehensively reflects the current COVID-19 data. It uses the query system in ontological form that is used to collect relevant information for answering questions formulated by experts from the US White House and the National Medical Academy of Postgraduate Education of the Ministry of Health of Ukraine. Information presentation subsystem in the form of interactive document is used for aggregated display of retrieved information based on control ontologies. The example of such control ontology is shown on slide 11. The information aggregation is carried by an ontological search prism, shown on slide 12, which is an extension of ontological prism and allows for dynamic ontology creation. For selected subsets of search query ontology, a dynamic extension is created by information retrieval system's internal storage. The relevant documents are selected from this storage, processed, and represented in a form of a search result ontology. A set of such ontologies are dynamically joined together by information consolidation module and then represented as ontological prism. So, in conclusion, in this work, we presented the main models of the theory of lexicographic systems and described their architecture. Using this theory, the modeling of ontology-driven lexicographic system is performed. The multidisciplinary ontology-controlled systems are considered, and the approach to their transdisciplinary integration is described. Thank you for your